And good morning, everybody. How are you doing today? Let me make sure my sound's cut off. Yep. Hope y'all are doing well this morning. Hi, Amber. Good to see you. Hi, April. Good to see you. Thanks for coming today. Thanks for coming last night to the webinar. It was great to see you. Hi, Jennifer. Good to see you. Amala. Good to see you. Okay, we've got a small but dedicated audience here today. Good morning, Julia. John. Wow, okay. Fantastic. Hope everybody's doing well. Thanks to those of you who came last night to the webinar. Yep. So last night, let's see. Last night's webinar. What in the world did we talk about last night in the webinar? We talked about language development, didn't we? Oh, no, we talked about ACEs and everybody's ACEs. If you remember from Tuesday when I was talking about the need for the developmental perspective, I suggested to you that it has led to a 32-year increase in the average lifespan of human beings. This is sort of what I was talking about. If you'll notice last night, we were talking about those factors, psychological factors early in life that can actually turn out to have physical implications. So I thought that was pretty interesting, and that's how that sort of ties into this week's lecture. Good to see you, Ryan. Thanks for coming today. All right. So let's go ahead and get started. We are at 9:01. So I'm going to go ahead and get started with today's lecture. So if you remember, let's go all the way back. We were talking about human development as occurring in three dimensions: a physical dimension, a cognitive dimension, and a socio-emotional dimension. Now, in Tuesday's lecture, basically I introduced the developmental perspective, and then I talked about neurological development that occurs in your brain and spinal cord as you mature. And so we talked about myelination and dendritic spreading, right? So I talked about that physical thing. Then I talked about measuring the quality of that neurological development by looking at milestone behaviors. And I suggested to you that there's several different categories of milestone behaviors that doctors follow: your gross and your fine motor behaviors, your cognitive milestones, your socio-emotional milestones, and your language milestones. All right. I then went over quickly, we sort of started talking about cognitive development, and I suggested to you that there were also language milestones that we could watch in children. So you're looking for your kid to say their first word probably around a year. You're looking for simple sentences to begin sometime late in the second year, along with this vocabulary explosion. Your kid suddenly will become more verbal in the second half of the year. And then we talk about the development of pragmatics. And if you look right underneath me is the sort of the language milestones that your pediatrician is going to be looking for. And this is cognitive development, but it also represents a demonstration that your neurological development is happening in a normal manner. Does that make sense to everybody? Okay. I then suggested to you that we could talk about how human beings change intellectually. And I introduced you to a fellow named Jean Piaget. Jean Piaget is one of the most important psychologists in the field. He has been cited or referenced by, his work has been referenced by other psychologists more than any other psychologist in history. So in terms of who's influenced other people, Jean Piaget would be the biggest influencer in the field of psychology. And he was the first developmental psychologist to suggest a theory of how the human mind unfolds. I'll bet you've never really thought about that. Have you ever really imagined how our minds go from zero to the brilliant people that are sitting in front of me? How does a baby, a helpless baby, go from no mental ability, so to speak, to abstract thinking abilities like calculus and biology and anatomy. I know some of you have anatomy and biology, anatomy and physiology tests coming up this week. How do you go from a baby to a person that can do that kind of ability? And what I introduced on Tuesday was the idea of Jean Piaget's theory of cognitive development. And he argued that human beings develop these really simple ways of organizing the world, relationships between objects that are called schemes. And what they do is they develop these schemes from simple to more complex. I suggested to you that babies are born with a set of reflex behaviors. All right. For example, the sucking reflex. Babies come with a feeding reflex that they don't need to learn. That's just a reflexive behavior. Put something in their mouth, they'll start to suck it. And so what he argues is that babies over the first month or two begin to realize that there's a relationship between sucking on a breast and a feeling of warmth, a good feeling in the stomach. And so babies develop a positive association, a little scheme, if you will. Hey, if I put something in my mouth and suck on it, it'll make me feel contented. He argues that babies then take that very, very simple behavior and test it out in the world, just like little scientists. And he argues that sometimes these behaviors turn out to be useful and they assimilate that behavior to that particular situation. And sometimes they find out that their behaviors don't work, that their scheme doesn't work. And then they have to change that scheme to make it accommodate the new information. So if you've ever seen an infant, what you'll notice is that they put everything in their mouth. If you talk to Jean Piaget, what he would suggest is that babies are finding out where that scheme, that very simple scheme, works. I can suck my thumb, that feels good. I can put dirt in my mouth, that doesn't feel good. And so they learn how to, they take this scheme and they see where it works. They assimilate and they accommodate this schedule. And I think on Tuesday I talked about my son's first word, dog. He started saying dog at 10 months and he thought dogs were four-legged furry things, right? And so every time we saw a four-legged furry thing, he would point and yell dog. And we would congratulate him every time he did that. And he learned that dogs can be tall, dogs can be short, dogs can be super furry, dogs can be short-haired, if you will. But then we took him over to a friend's house and he pointed at their cat and he said, dog. And we all started laughing because he had misapplied his category. He had misapplied his scheme. And so we explained the difference between dogs and cats to them. And so my son changed his scheme. He adjusted his scheme so that he had a scheme for a dog and a scheme for a cat. And so Piaget argues that human beings build on the simplest reflex behaviors all the way up and begin building more and more complex schemes. Dogoo, there you go, Ryan. You got it. Dogoo. Nice. Okay, now here's the deal. Piaget believed that human mental ability evolved into four distinct stages. So in his study, he did lots of case studies and natural observational studies with children in infancy. He actually studied his own children in infancy when they were born. He would study them in the crib. He spent some time studying preschool children too. And then he spent some time in schools, in elementary schools, looking at children. And he would look at how they would play, how they would act in the classroom. He would ask them thought questions and logic questions to see what they could answer. And he began to realize that children, in a sense, evolve into four stages of mental ability. 4 stages of mental ability. And what I'd like for you to do is to appreciate the different qualities of these intellectual abilities. Now, while they happen at sort of typical age times, really the ages aren't the important thing. Instead, he argued that we evolve through these in the proper order. Some kids evolve a little bit quicker, some kids evolve a little bit slower. But he argued that the mind goes through 4 distinct stages of ability. What I'm going to do quickly is go over those 4 stages of intellectual ability. Okay? Now, the first stage, he argued, was what he called sensory motor. He named it sensory motor because he believed the child was living in a world of physical experiences. He argued that children at this age were pre-symbolic. That is, they couldn't hold ideas in their mind. He said, so therefore, they were stuck in a world of senses and motor movements. And he argued that at this stage, for a child, out of sight was out of mind. So your child might see a pretty ball in front of them, and they might want that ball and cry if you didn't give it to them. But as soon as you hid that ball away and the child couldn't see it, according to Piaget, that ball was gone, because for children, he argued that they were pre-symbolic at this stage. They were stuck in the world of sensory experiences and motor behaviors. So we call it the sensory motor stage. So he argued that your child is pre-symbolic and largely unable to form mental representations of experiences. And so he argued that children move from these simple reflexes, like sucking the thumb, like moving the hand, like looking at things. Hearing something and knowing to turn your head to look at something is also a scheme. And so he argued that children move from reflexes to schemes during this first year. And he argued that there were 2 major milestones that a child had to achieve in order to move out of the sensory motor stage. Now, one of the neat things that you will find with a 6-month-old baby is that they seem to demonstrate the out of sight, out of mind principle. That is, they do not appear to have what's known as object permanence. You and I know that objects exist even if we can't see them. So, for example, I might ask you, do you have a car? And I'll bet all of you right now out there listening to me would say, of course I have a car. And I would say, but you can't see it. And you would say, no, but I know it exists because I've got it here in my mind. You've got object permanence abilities. Now, the nifty thing is with Piaget, he would take a child and show them a toy and establish that the kid wanted the toy, that the child would reach towards it and try to grab it, the little 9, 7 or 8 month baby. And the baby would want to grab it because it had a schema for grabbing things it liked. And he would establish that the baby wanted the toy, and then he would put the toy down and he would put a blanket over the toy. And he found that as soon as he covered the toy, the child would just start looking around almost as if it had forgotten that the toy existed. So, in Piaget's mind, children did not have object permanence. They seemed to forget that objects existed even when they couldn't see those objects. And I guarantee you, if you folks take your 8-month-old baby, you can do this demonstration at home, or you can watch ones on YouTube. You show the baby the toy, you establish that the baby wants the toy, and the baby will reach out and start grabbing the toy. You then put it down and cover it with a washcloth so that the baby can see the bump but not the object. And I guarantee you that baby will just stop looking for it and will start looking around and doing other things, almost as if it's completely out of their mind, right? Now, Piaget argued that this sort of was an ability that developed during the 2nd year of life. And it turns out modern research has suggested that children don't seem to begin to demonstrate object permanence until around 7 or 8 months of life. And there are even demonstrations you can do with 12 and 13 and 14-month-old children demonstrating that they don't have perfect object permanence. So this is sort of an ability, a symbolic ability that develops during the first couple of years of life. Now, the second symbolic ability that he demonstrated children under 2 can't demonstrate is what's known as objective self-awareness. Now, I'm sitting here lecturing to you right now, and I get to see what you're seeing. And so I see my little picture right up here. I see my picture. And I can tell that that guy in the screen is me. And I'm watching my lips move, and I know that that is me. I have objective self-awareness because I can recognize myself as an object. One of the neat things that you will find with children, with infants, is that they do not start out with a sense of objective self-awareness. So you see this picture below me, there's a child looking in a mirror. Notice that that child has a black dot on its nose. So what the experimenters do is they secretly put a little mark on a child's face. They'll put it on the nose here. I've seen it done on the forehead, but you do it so that the kid doesn't know that you're marking their face. You then put them in front of a mirror. And what you do is you look to see if they realize that there's something on their face. So what we're looking for this young boy to do is to look in the mirror and see that black spot on his nose, and we're looking for him to rub his nose. And that would demonstrate that this child understands that he's looking at himself in the mirror. And what you're going to find is that children around 10, 11, 12, 13, 14 months are going to look in the mirror and not realize that they are looking at themselves. And only as we move into the second half of the second year do children really begin to demonstrate this understanding of themselves as an object. This little kid right now, he's pointing his finger. He thinks he's looking at a friend or someone else. He doesn't realize that he's looking at himself in the mirror. And so this child doesn't have objective self-awareness. So what Piaget suggested was the first 2 years of your life, you are in a pre-symbolic period. He said he realized this, he knew this, because children at this age didn't have object permanence and they didn't have objective self-awareness. These are two very fundamental ways of representing objects as symbols. Does that make sense? If you can think about an object when it's not here, that means you've got the symbol in your mind. And if you can recognize yourself in a mirror, that means you have a representation of your mind of what you look like. And what he demonstrated was children in the first year or so of life did not have this symbolic ability. And so he called these children sensory motor. Okay? Now, he then argued that when children develop symbolic ability, it really explodes and they go through a second stage where they're symbolic but not very logical. Now, let me ask you a question. How many of you believe in Santa Claus? How many of you believe that Santa Claus delivers toys to everyone around the world on Christmas Eve night? Do any of you believe that? Hi, Ronnie, good to see you. We were just talking about Santa Claus. How many of us believe in Santa Claus? Why don't you believe in Santa Claus is the harder question. Why don't you believe in Santa Claus? Can someone tell me? Okay. Well, because Santa Claus doesn't make any logical sense. It's absolutely illogical to think about a guy flying around the world in a sleigh pulled by a bunch of deer. You have to play the role of Santa as a parent. Right now it's your job. But it just doesn't make sense, does it? Right? It's illogical. It just doesn't make sense. And you know what? Every child, every 4-year-old in the world accepts the idea of Santa Claus uncritically, right? Every kid in America believes in the Easter Bunny, who brings you candy in April. Or how about the tooth fairy that comes around and pays you money for the teeth that fall out of your head? These are ridiculous, crazy stories that we tell children. And you know what? Children believe these because they're symbolic, but not necessarily logical. And so what he demonstrated was children from around the age of 2, when they become symbolic, to around the age of 5 are symbolic, but not very logical. And he demonstrated this by showing that children cannot engage in a logical task he called conservation. Okay? And he showed that children also have animalistic beliefs. That is, they can't draw the line between things that are alive and things that are dead. And he found that children have a distinct inability to understand someone else's perspective. And I'm not talking about a deep, empathetic understanding of where a person's life experiences have brought them from. That is, these children don't understand what somebody else in the room can see based upon where they're standing, in which direction they're looking. Okay, so he demonstrated that children have very specific logical deficiencies at this age. And he argued that if you look at these children from around age 2 to 4, they are really off the map in terms of logical abilities. They have no logical abilities at all. And he argued that as they get a little bit older, 4, 5, and 6, these logical abilities will begin to sort of appear. And so he even divided this stage into sort of 2 substages, if you will. And he argued that children are pre-symbolic, are symbolic but not logical from around 2 to around 7. Now, how did he do this? He did these things he called the conservation task. Do you understand that a quantity of something doesn't change its quantity based upon how it looks? So look over on the far side of this screen. I've actually got videos demonstrating children failing these tests, okay? But I can't play a video in here, so I'm just going to have to describe it to you. If you'll see in the top frame of this picture, they show this girl 2 glasses of liquid, and they ask the person to adjust the water in the glasses until they have the same amount of liquid in both glasses. And so what they'll do is they'll get the child to do that, and they'll make sure that the child knows we have the same amount of liquid in both glasses. They then take the water from one of those glasses and pour it into a taller and thinner glass. And they do that in panel B. And you notice in panel B, they're pouring that water into the taller glass. Now in panel C, you can see that the water now looks taller in that skinnier glass than it did in that short, fat glass. Has the amount of water changed at all? And you folks know, of course not. It may look different, but it's the same water I poured from this glass. You are able to conserve liquid. You understand that the amount of liquid doesn't change just because it looks a little bit differently. What you're going to find with a 3-year-old child is that when you do this task, they're going to say that there's more liquid in the tall glass than there is in the short glass. That's wrong. That's illogical. The child hasn't demonstrated an ability to conserve liquid. Now you can do this same trick with mass. So you can take 2 balls of clay, all right, and get 2 balls of clay that the kid says are exactly the same size. You can then take one of those balls and smush it out and turn it into a long tube of clay. And the child will think that the long tube of clay is bigger than the short ball of clay, even though we have the same clay in both examples. In the video that I've provided for you in your course resources folder this week, they ask a child to look at 2 rows of quarters, right? And they established that there are 5 quarters in each row. The experimenter then takes the quarters on the bottom row and spreads them out, so it's a longer line of quarters. Still 5 quarters, but instead of being 5 quarters in 6 inches, it's 5 quarters in 12 inches. And he asks the child, do I have more quarters up here or down here? And he finds that the kid is tricked by the fact that their quarters are stretched out into a longer line. So do you understand that? Basically, your book's going to talk about these things called conservation tasks. And what he found was that children are not able to conserve the properties of objects. They judge them based upon how they look, rather than how they actually are. So children are sort of illogical, if you will. All right? Now, he also, if you look at this child right below me, he's demonstrating an inability to understand someone else's perspective. This child's going to demonstrate egocentrism, and I've actually got this video in your course resources folder right here. Now you see this child, they're showing him the famous 3 mountain task. You see there's a diorama with 3 hills on it. And there's an animal on one side of this mountain, and there's a pine tree on the other side of this mountain. Now, if you're sitting where the boy is, you can see the animal on your side of the mountain, but you can't see the tree on the other side of the mountain. What they're going to do is they're going to take this little boy and walk him from one side to the other side. And they're going to ask him, what do you see here? And he's going to say, I see an animal. They're going to take him over to the other side and sit him down, and they're going to say, hey, what do you see? And he's going to say, well, now I just see a pine tree. All right. They're then going to put a stuffed animal on the other side of this child, and they're going to say, tell me what the animal sees. And what this kid's going to say is, if he's sitting here, where he's sitting right now, and you put the stuffed animal over near the pine tree and ask this kid, what does the stuffed animal see? This child's going to say the stuffed animal sees the animal. Does that make sense? Right? Now, if you took this boy and put him on the other side where he could only see the pine tree, and put the stuffed animal where he's sitting, and you ask this boy again, what does the stuffed animal see? This little boy will say the stuffed animal sees the pine tree. So in a sense, when this kid is asked to make a judgment about what somebody else sees, they're going to think about what they can see, and they're going to substitute their perceptions for what somebody else might see. Does that make sense right now? Does that make sense? So if you didn't have this egocentric ability, April, let's say you're sitting in your living room right now, and let's say you have a toddler son sitting there with you. If somebody said, April, can Dr. Roddenberry see your baby? You, of course, would say, no, Dr. Roddenberry can't see my baby because he's on my computer screen. He's not actually in this room. But a pre-operational child will make that mistake. And a pre-operational child would think that Dr. Roddenberry could see through this computer screen and see into your living room. I hope that makes sense. All right. Now, and he would also ask children to seriate, that is, arrange objects from smallest to largest, lightest to heaviest, shortest to tallest. And what you're going to find is that pre-operational children are not great at that. They can do that, but it's lots of trial and error in figuring that out. Okay. And, okay, good, Ron. What's confusing you? Basically, what he showed is when you ask this little child what somebody else sees, he's going to report what he can see. So, Ronique, can you see my suitcase? I have a suitcase in my room. Can you see my suitcase? And you would probably say, no, I can't see your suitcase because I'm in a completely different room. All right. If you asked me and I was a pre-operational child, I would say, of course, others see what they can see. Exactly. They don't understand that people have different visual perspectives. Maybe that's a better way to put it. Okay. They're also not great at classifying objects, especially on multiple dimensions. I remember when my child was a toddler, I wanted to give him a task to do. So he would help me put the silverware from the dishwasher into the little silverware drawer. I'm sure all of you have a silverware drawer where you have your forks, your spoons, and your knives. And what I found is that my 2 and 3-year-old was not very good at putting the knife with the knives and putting the forks with the forks and putting the spoons with the spoons. He just wasn't great at classifying objects, okay? And so what he argues is that children from 2 to 7 don't have a great sense of other people's perspectives. They're not really logical, and they have trouble doing what you and I consider educational tasks. So kids are they're symbolic, but not logical. Now, if we have any teachers in here, if any of you are teachers in here and you are going into elementary school teaching, one of the things that they're going to talk about, they're going to talk a lot about Piaget in your education program. And especially if you're going into early childhood education, they're going to suggest to you that your children in elementary school are logical and you can teach them, but they have certain limitations, which means you have to teach them in a certain way. So from 7 to about 12 years of age, which is what we would call the elementary school age, your children are going to be logical, but not good at abstract thinking. So if you give an 8-year-old a conservation task, they will pass it every time. In fact, they will laugh at you because it makes such obvious sense. An 8-year-old will be able to demonstrate the ability to understand somebody else's visual perspective. An 8-year-old will be able to seriate and classify and do mathematical ability. They are logical, but they are not great at abstract thinking. Instead, children reason better about things that are either A, very familiar, or B, very, very concrete. So children at this age need to engage in hands-on learning. I don't know if any of you ever learned about the planets in elementary school, but when I was a kid, we would learn about the planets by going to the craft store and getting styrofoam balls of different sizes. And so you had to get a big styrofoam ball for Jupiter, and then you had to get a medium styrofoam ball for planet Earth, and then you had to get a teeny tiny styrofoam ball for Mercury and Pluto. And we did that to represent the various differences in size. Now, your teacher could have just given you the relative diameter of these circles and said, hey, Jupiter is 10 times the diameter of Earth, but that's an abstract concept, you know? So instead, your teacher brought in something that you could look at and you could touch so that you could see the differences. I don't know if you ever talked about the Declaration of Independence or the Constitution in elementary school, but I'll bet your teacher made you all dress up and pretend to be different of founding fathers. So somebody had to give the Patrick Henry speech, somebody had to give the Thomas Jefferson speech, somebody got to pretend to be George Washington. And so your teacher did the learning, but instead of talking about truth and justice and liberty, your teacher actually had a Continental Congress in class, right? And if you've ever been to museums, you'll notice that they always have a kids zone in the museums. And the kids zones always have stuff that the kids can play with, that they can touch, that they can feel. And the idea is that children during elementary school are logical, but they're not very good at abstract thinking. So what you have to do is you have to do a lot of hands-on learning with elementary school children. Does that make sense? Does that make sense? Now, Piaget then argued that we evolve into our final intellectual stage when we become both logical and abstract critical thinkers. Now, Piaget said not as many people as you think get into this stage. Not everybody makes it into true formal operational thinking. He argues that most people aren't good critical thinkers except in the place where they work. The only way, he said, most people do most of their critical thinking at work. And most people don't think critically very well outside of something that they do every day. But he argued for some of us, we develop what he calls formal operational abilities. And this occurs as we move into our teenage years. And he argues that children are able to reason abstractly as well as concretely. Now, if you've ever been a child, I'm sure you've done something stupid and broken something and had your parents ask you the question, well, didn't you think that this would happen? Did you not think that if you did X, Y, and Z, you might break this or break that? And you as a kid said, no, I never really thought about that. Well, if you didn't, then you didn't engage in what Piaget calls hypothetico-deductive reasoning, which is the ability to imagine future outcomes. Hey, if I spend all of my time drinking alcohol instead of studying, I won't pass school. Well, that's a hypothetical reasoning about what's likely to happen in the future. Let me give you an example. When I was an 11-year-old boy, I was living in an apartment complex up in Chicago, Illinois. And we used to play tennis ball, baseball in this little tennis court. And our tennis court backed right up to an apartment building. And we would hit the tennis ball and somebody would pitch it. And if you hit it over the tennis court net, it was a single. And if you hit it out of the tennis court, it was a home run. And occasionally, you would hit the tennis ball so hard that it would fly out of the tennis court across the quad, and it would hit the apartment building that faced the tennis court. But it was no big deal because it was a soft tennis ball and it would just bounce right off the house. And it was always kind of cool to hit a home run off of the apartment building. Well, then one day I got the brilliant idea. Hey, let's play with a real baseball in the tennis court. And guess what happened after about a half an hour of playing baseball on that tennis court? Can any of you tell me what bad thing happened after about an hour of playing baseball on that tennis court with a hard baseball and a bat? Can anybody imagine what happened? Broken window, absolutely. I hit a smash of a home run out of the tennis court, across the quad, and right through the second floor window of that apartment. Do any of you know what happened next? Can any of you guess what happened next? We all ran. You betcha, buddy. We all ran. But it never occurred to any of us that hitting a baseball could lead to a broken window. That's because we were not in what you might call formal operational thinking. We weren't thinking about the future consequences of our behavior. You damn right we took off running. Absolutely. Now, a good demonstration might be, and I put this funny picture down here of a kid with a big thumb. One of the things that they'll ask children, what they'll ask children to do is to say, how would the world be different if people didn't have thumbs? And what you're going to find is some people will give very concrete answers. Well, we wouldn't be able to play video games. Well, we wouldn't be able to strike a lighter or use a lighter. And they give concrete answers. And some people will give more abstract grand answers. Well, the entire world would have to be designed differently. Oh, we probably wouldn't evolved into the people that we are now. So what he found was some children gave very concrete, simplistic answers to this hypothetical question, and other children gave very deep, detailed, abstract answers to this question. And he said that this demonstrated that some children were thinking formally and some children were not thinking formally. You're right, we definitely blamed it on the ball. Okay? Now, so in a sense, this is what I want you to think about. Think about our intellectual ability, our cognitive ability, as evolving into 4 distinct stages where our thinking is just becoming more complex and more organized. And we are creating more complex and more complex schemes. Remember those schemes from the beginning. And so we go through a pre-symbolic period, then a symbolic but not logical period, then a logic but concrete period, and then we go into our final ability where we can hopefully think logically and abstractly. Okay? Now, not only do our abilities increase as we mature, but you know what? The developmental story also includes decreases in our abilities. So not only will our physical abilities, cognitive abilities, and socio-emotional abilities show positive effect, positive change, but part of the developmental process is these abilities sort of waning as we get older. So there are people who are interested in trying to understand how our minds change as we move into later adulthood. We all know or feel like we're not as sharp as we get older, but exactly how does it happen? When does it happen? And why does it happen? Now, I'd like to talk to you briefly about this famous study called the Seattle Longitudinal Study. This is what was known as a cross-sequential study, where they actually followed people of different ages over a period of time. So they started out this study with people who were 8, people who were 18, people who were 28, people who were 38, people who were 48, and then they followed these people for 30 years. So how did the 8-year-old change from 8 to 38? How did the 18-year-old change from 18 to 48, 28 to 58, 38 to 68, 48 to 78? And they were interested in trying to understand how do their intellectual abilities change? And what they found was that really intellectual decline, typically you're going to see it start to occur in the 70s, but not for everybody. One of the things that you can do to protect yourself from cognitive decline in late adulthood is make sure that you get lots of exercise as you get older. Aerobic exercise and cardio works as a protective factor against the loss of intellectual abilities. And in fact, if you do that, you can push that cognitive decline off into the 80s or 90s. So you do not have to begin losing your intellectual abilities at 60 or 65. That is absolutely not true, right? Now, however, your mind is going to change as you move into the 60s and 70s. And if you look at the picture right underneath me, it kind of shows you how these abilities drop off. So you can think of your intellectual ability in sort of 2 broad forms. There's what we might call your crystallized intelligence, which is your knowledge for facts, your memories, all the things you've learned, all right? And let's think of fluid intelligence as your problem-solving ability, your intellectual ability, your ability to solve problems and to think creatively, all right? And so what you're going to notice is that your creative thinking, your flexible thinking, your speed of thinking is going to begin to decline much earlier than your knowledge. So you're not going to forget things. That's not the part of your intellectual functioning which changes as you get older. It's instead your flexibility of thinking and how quickly you think. Okay? Now, dementia, there are lots of different kinds and causes of dementia, and basically it's going to be just a dramatic loss in intellectual functioning and mental ability. Now, Alzheimer's is the most common type of dementia in later adulthood. Typically, it's not going to set in until after you're 65 in your 60s or 70s. But you know what? There are some people who have what's known as early onset Alzheimer's. Now, there is no way to prevent or cure Alzheimer's disease. No way to prevent or cure it, unfortunately. Alzheimer's disease occurs when you start developing plaques or tangles in your neurons, and these plaques and tangles start killing your neurons. Now, for those of you that are in biology class, you've probably heard of microtubules and other sort of structures that give your cells shape. So if you think about it, cells have skeletons, if you will, that kind of give them a shape. And so they have these proteins, these microtubules in there that sort of give the cell shape. And what happens is in people with Alzheimer's, these microtubules and these proteins inside of their cells start growing exponentially when they shouldn't, and they sort of clog up the cell and kill it. And so you get plaques and proteins growing in the neurons, and it starts to kill brain cells. And as these Alzheimer's related cell death occurs, it begins to take away the person's intellectual abilities. And what you're going to notice, the cell death usually goes from the front to the back. So memories and personality are going to change first. And then the person towards the later stages of Alzheimer's is going to lose memories for things like walking and how to use a phone and how to use a fork. And they're going to lose sort of these more deeply placed kinds of learning abilities because those are mediated by areas in the back of the brain. And so this is sort of the other side of the intellectual ability, intellectual change which occurs as we move through our lifespan. Now, I did not even get to the second part, attachment, socio-emotional development. I'm going to spend 10 minutes talking about this. One of the most important socio-emotional, why is there no cure? Because it's sort of a biological process that can't be stopped. There's no way to clean the proteins or the plaques once they start occurring, Ron. Actually, in fact, you don't get a final diagnosis of Alzheimer's until you die and they do an autopsy. Alzheimer's is typically diagnosed using behavioral indicators, so you start having these memory problems. But basically, we can't stop the protein in the plaque growth, Ronnie, and it just kills brain cells. That's why there's no cure. So I want to talk briefly about socio-emotional development. And I want to talk about a very important critical period in every mammal's life. And this is the early attachment period. In the first part of your life, mammals, because of their big brains, are born unusually helpless compared to other reptiles and other organisms in the environment. So it is important for mammals, especially mammals with more complex behavior patterns, to have a fundamental protective relationship between the mother and the offspring. And this relationship allows the baby, the developing organism, the time to develop until their brain matures enough to give them their complex social and intellectual abilities. Babies are incredibly helpless, so it is evolutionarily adaptive for babies and mommies to like one another. And this bonding between a baby and a primary caregiver allows the baby to survive when it is most helpless. And so we're going to talk about attachment as a fundamental mammalian need that serves a survival that has a survival benefit. And we call this attachment. It's the close bond between an infant and a primary caregiver that develops during the first year of life. Now, a very famous psychologist named Harry Harlow was interested in asking the question, why do infants bond with their primary caregiver? Is it because the primary caregiver feeds them? Okay. Or is it because there is something deeper, some sort of deeper need that the organism has? So why do infants bond with their caregivers? Is it because of food or love? If you look over in the far left-hand corner, I have a picture of Harry Harlow's famous monkey study. And you'll see that he takes this little capuchin monkey. Now, this capuchin monkey has been separated from its mom at birth. Kind of cruel, right? And he takes these monkeys and he raises them in complete isolation. Now, in their cage, he puts two moms. And you'll see this monkey has two moms on the left panel. One of the moms is covered in soft terry cloth and is very comfy and snuggly, all right? If you'll see, the other mother is a wire mother, but they didn't cover it with the soft terry cloth. Instead, they put a feeding bottle in with that mother. And they put these two mothers in the cage with the infant. And that's the only caregivers that this little infant monkey has. And they ask the question, where will the monkey spend the most time? Will it spend more time snuggling on the mom that has the bottle and feeds it? Or will it snuggle on the mom that's softer and more comfortable? And what Harry Harlow found was that these monkeys spent 23 and a half hours a day snuggling on the warm, soft mom. The only time they went to the other mom was when they were hungry, and they would feed and come all the way back, and they would come back immediately to this warm, comfy mom. Now, he did some really cruel experiments where he would go in and he would scare these monkeys and see which mother they ran to. And he found that the monkeys, when they were scared, they always ran to the soft, cuddly monkey mom. And so he found that babies had a need to attach with a primary caregiver, and they do this for comfort and not so much food, not so much food. Now, the reason that this occurs is because maybe as a child, as an infant, you've got this amygdala, this emotional center, and you're experiencing all of these crazy emotions, and you're really quite helpless. So there are a lot of times when you are afraid. And this attachment to the mom allows you to manage those anxious feelings so that you can explore. Remember, I told you on Tuesday, in order for a brain to develop, it needs to be stimulated. And animals stimulate themselves by exploring. And so what you'll find is that by bonding with the mother, these infants become comfortable, and then they engage in little exploratory behavior. If you ever watch an infant baby and their mom, what you're going to notice is that babies will explore around their mom, but they'll always turn to look every couple of seconds to make sure that mom's there. And as long as a baby is sure that their mom is around, they'll explore. But as soon as a stranger comes in the room, or as soon as the mom gets up for a second, the baby will turn and freak out, and all they'll want is their mom. Okay? No, I don't remember a sock puppet, Ryan. I don't remember a sock puppet. But in a sense, the reason that this happens is it allows the organism to manage their fear, their anxiety, so that they can explore, because exploring stimulates the brain, which leads to intellectual development. Now, real quickly, a very famous researcher named Mary Ainsworth was interested in understanding if there were different sorts of relationships between moms or primary caregivers and their infants. And so she wanted to see if she could measure different attachment styles. So she did a very nifty observational experiment where she manipulated two very normal fears that children have. Infant children have stranger anxiety and separation anxiety. That is, from around the age of 6 months to about 2.5 years, children are very afraid when they get around a stranger, and they will go back and cling to their mom for protection when they're around somebody they don't know. And children really freak out when their mom leaves them alone. That's called separation anxiety. And so children have these very two normal anxieties or fears. It's a part of the attachment process that occurs starting around 6 months when the child develops the intellectual ability to understand that mom is an object. And it takes till about 2 to 2.5 years for these fears to go away. Now, what she did was what's called a strange situation experiment. She brought these children in with their mom, and their mom is with them. Now, the mom's sitting in there. It's a 12-minute experiment. And so the mom's sitting in there and the baby's playing with the mom. And then a stranger comes into the room and it freaks the baby out. And then excuse me, I take that back. First, the mom gets up and leaves the room so that the baby's alone. And then the mom comes back into the room after a few minutes, and the baby comes back and hugs mom. And then a stranger comes into the room, and then mom gets up and leaves, so the baby's alone with the stranger, and then mom comes back into the room. So over 12 minutes, they separate this baby from its primary caregiver, either making it having it so that it's in the room all by itself, and having it so it's in the room with a stranger. Now, what happens is when the mom comes back into the room, the experimenters watch carefully what that baby does. And what Mary Ainsworth found was that children displayed 3 different ways of bonding with the mother when she came back in the room. Okay? And she called these bonding styles attachment styles. And so she found that about half the children, when the mom would come back in the room, the baby would be crying, the baby would crawl over, hug the mom, and as soon as the baby started hugging the mom, its anxiety and crying stopped, and the baby became normal and would go back to exploring in the room. And Mary Ainsworth said that these babies had what's called a secure attachment style. They were able to rebond with a person quite quickly. Now, some of those babies, when mom came back into the room, they were super duper clingy. They would have trouble stop crying. They would crawl back to mom, but they wouldn't let go of mom. They wouldn't calm down, and they wouldn't begin exploring. She argued that these babies were what she called ambivalent babies. They were very, very clingy. And she found about 20% of the babies did that. And then she found about 20% of the babies were avoidant. They seemed mad at the mom when she came back. And the mom would pick the babies up, but the babies would push themselves away from the mom and not look at the mom. And they would cry, but they would punish the mom. And she found that these babies, she called these babies avoidant. Now, why should I care about this? Well, it turns out people have suggested that your adult relationship style might be related to your infant attachment style. And I'm going to leave you with this scale right here. Have any of you ever dated a partner who was super clingy and who couldn't be separated for a moment from you? Have any of you ever had a partner that wouldn't share with you, wouldn't share any intimacies with you, was always closed off? You may have had an anxious or an ambivalent relationship partner or an avoidant relationship partner, because there is evidence to suggest that your infant attachment style sort of serves as a model for how you interact with the world as an adult. Okay, I am so sorry I have gone over my lecture time by 8 minutes. I got behind on Tuesday, and I was trying to catch up. I still missed some stuff. You're going to have to read about Erik Erikson on your own for the exam. If nobody has any questions, I'm going to go ahead and shut off this broadcast. If you need to talk to me, don't hesitate to send me a text or an email. and we can sort out any problems you may have. Have a great day. Take care. Hope to see you in webinar tonight. Don't forget to do the discussion board. Have a great day.